Okay, today I am going to discuss some of the problem of the first year vector calculus of BSc Physics. I will be explaining some of the important question as the partial examination is coming soon. So I am going to discuss. There is one problem which asks us to prove that the call of the gradient of phi is equals to 0, and this is one of the very important question, and this question is repeatedly being asked from the year I guess 2060 BS. So we have to prove this is equals to 0. So before starting about the problem, we should have the idea about the what is call and what is gradient. The call is just talking about the call. It is just the cross product that we study in our +2 level, and gradient is just the way of converting the scalar function into the vector function. So let's discuss. Let's prove. So I will be taking the left hand side. So it is the symbol for the call is the nabla times the gradient of phi, and here the phi must be the scalar point function, otherwise this doesn't work. The gradient is only used before the scalar function. Scalar function means it don't have any direction. So we know the value of the delta. We know that the delta is always equals to I cap the partial derivative operator with respect to x plus j times the partial derivative with respect to x and k times the partial derivative with respect to z. This is actually describing the space, the three-dimensional space. Look, the I cap, j cap and k cap. I cap, j cap and k cap. Okay, I will be substituting the value which is I times the del by del x plus j times the del y plus k times the del y del z cross. Here is the phi, which is a scalar point function. Okay, and here is the phi. On the basic, from the basic arithmetic rule known as the distributive property, we have to distribute this phi to the each of the term. This is 3 term, as there is the addition symbol here. So here is 3 term, 1 term, 3 term, 2 term, and 3 term. So we have to distribute this phi to the all of the. So I am rewriting this rho x. This is actually del, but I am pronouncing it's rho. Actually it is del or del, yes. So I times the phi plus j times d phi. So here is the cross. This is generally for the call. We know the traditional method for finding the cross product of the two vector. We have to write the I, j, k, and we have to write the components of the a here and components of the b here, and we should find its determinant. So we will use the same method here as well. we use the same method here. Let me check the camera once again. Okay, it is capturing the information on the board. I think I have to drop something, some drop for my some area. Okay, I will drop this one. So for finding the cross product, we have to write here the I, j and k, and writing the first vector, the coefficient of the I cap, the coefficient of the j cap, and the coefficient of the corresponding k cap. So we will be writing del by del x, del by del y, and del by del z. And for here it is del phi by del x, del phi by del y, and del phi by del z. So we have to calculate its determinant, and I'm sure you all are pretty confident about finding the determinant. First we have to write I. Then we have to hide its corresponding component, this horizontal and this vertical. So remains these things. So for finding the determinant, we have to multiply this. We have to cross multiply this, and also we have to cross multiply this, and we have to insert the negative sign over the center. So I am writing I am multiplying this one. So I will be adding the negative sign over here. Then I will be going upward. So del by del z times the del phi by del y. And for the j, we have to insert the negative sign. This is something confusing, but it is. I will explain the reason of the negative sign some days. So I will be hiding this one. And this one. So there remain del by del x and del phi by del z, and del by del z, del phi by del x. So I will be writing there. So it is del by del x, del phi by del z, and then this one and this one, minus del by del phi by del x, times the del by del z. So I'm sorry, the things are not capturing here, so I have to modify my camera here. And for the k, I will be writing here plus k times the I will be hiding this one and this one, and these are the things that is remaining here. So del by del x times the del phi by del y, minus del phi del by del y times the del phi by del x. So I'll be doing some basic differential simplification. The product of del and del phi will be del to phi. It is not the del square phi, it is del to phi. And here as well, del to phi. Del to phi. Similarly here as well, del to phi. Let's go down del to phi. Del to phi, del to phi. So we are at the end of the proof, and here this is del to phi by del y times the del z, and this is also del to phi by del z into del y. It is just the analogous, the del y into del z and del z into del y, they are same. 2 into 3 and 3 into 2 are same. So these are same. So the subtraction from the same quantity is always equals to 0 in the ordinary algebra. So this is equals to 0. I cap times the 0 minus j. And del to phi by del x times the del z, and del to phi by del x into del z. These also cancel out and the value will be 0. Similarly, this is also the value will be 0. So 0 multiplied by 0, 0, 0. So it is equals to 0. So the value of call times the gradient of phi equal to 0. Therefore, the call of gradient of phi is equals to 0, and this is being asked for the 4 marks. So after doing all these things, we will get our 4 marks for sure. Okay, thank you.